Hi, I'm Michael Bowen. I'm a Senior Escalation Engineer on the Office Open Specifications team. In this session, we'll explore how to apply the Azure AI Vision SDK to analyze images in a PowerPoint presentation and add any missing image descriptions. We'll achieve this by developing an app that leverages the Open XML SDK for modifying a PowerPoint document and integrating image descriptions generated by Azure AI Vision into the presentation. For those interested in following along and building their own project, there are some prerequisites. Ensure you have Visual Studio installed, the free version will suffice, plus .NET 8 or higher, and a program capable of opening a PPTX file like LibreOffice Impress or Microsoft PowerPoint. You'll also need a free Azure account for accessing the Azure AI SDK. The application we're building today leverages the Open XML SDK to manipulate a PowerPoint presentation and add missing descriptions to images in the presentation. To do this, we'll leverage the OO XML SDK's strongly typed classes to update the underlying file format of the PowerPoint presentation with descriptions from Azure AI Vision. To get started, let's take a look at how the Office Open XML file format works. The Office Open XML file formats constitute a series of file formats used to store Office documents, including PPTX, DocX, XLSX, alongside others like DocM and PPTM. These Office Open XML documents are stored in a zip format that holds XML files, various data files, and metadata describing the relationships between them. Depending on the type of document, the packages have different internal directory structures and names. The Office Open XML file format is based on the zip format. To see this for yourself, take an Office file and rename the extension to .zip and then unzip the file to see the contents. The example on the right is a PPTX file. You see here that it consists of a presentation XML and several slide XML and slide layout XML files and others. How these files relate to each other is described in the Rails file. The presentation part, for instance, is a key component of a PowerPoint's file structure. After extracting the contents of the PPTX file, we can examine the XML of the presentation part, which includes a slide identifier list or SLD ID LST element, which in this particular example contains two slide relationship IDs with an RID property describing their relationship to a slide XML part. To identify the specific slide that each ID corresponds to, we consult the relationships file for the presentation element named presentation.xml.routes. This file contains two relationship entries, which are highlighted in yellow, indicating that in this instance, RID3 links to slide 2 XML and RID2 to slide 1 XML. Various parts may have distinct relationships with others, and these connections are outlined in their own relationship files. This diagram shows the basic structure of a presentation. At the center, there is a presentation package that relates to other parts, such as theme parts, and slide master parts. Some of those parts, in turn, relate to other parts, such as the slide master parts that relate to the slide layout parts. In our application, it's going to deal with adding descriptions to the pictures, so we need to find the pick elements from each slide part. Opening a slide part, there will be XML similar to this. At the root of the slide part is the SLD or presentation slide, which contains all the elements that describe the objects and their formatting. In this XML, we want to find the pick or picture elements. In this case, there's only one, but there could be 0 or more. For a picture element, we must look through its child elements to locate the non-visual properties CNVPR element and identify the description property. It is this property that defines the caption. For example, in this description, it says it is a shark. As I described, these are just XML files, so it's possible to work with them directly to add the descriptions to the images. You'll have to first unzip the PowerPoint file into another file to unzip it. You need to get the path to the presentation XML file. You'll create an XML document to read it. You'll load in the path to the presentation XML. From that, you can get an element list of the slide IDs. Then you can create an empty list to store your relationship IDs and an empty list to store the paths of the slides you need to look at. Then you can go in a loop over all the elements in the element list of counts for the SLID elements. Then you can get the attribute from the RID and its value and store that. And as long as it's not null, you can add it to your list of relationship IDs. Once you have the list of relationship IDs, you'll need to create a new XML document to read the presentation relationships file. You can load in the root path and go to the presentation XML.rels, which is its relationship file. You can get a node list from that XML document by the tag name relationship, and then you can for each over each node in that list, and then for each node in that list, if the ID matches one of the IDs from your ID value of the slides, then you can take it and you can use that slide path and you can get the target value, which is the path to the slide you need to open, and then add that slide to your list of slide paths. Once you've done that, you need to add an XML namespace manager for the P namespace that's coming up. Now that we have our list of slides, we can take another for each loop and look at each slide. We'll create a new XML document, load in the slide, and we can get a list of our picture elements. If it's not null, then we can loop over each one of the picture elements, XML nodes, and then get its non-visual picture property node. And then, if that's not null, we can select the CNVPR property, and from that we can get its description and get its value, and that will give us where we need to add the description that we're getting from the Azure Vision AI. Now, that was a bit over 90 lines of code to access the presentation property for a picture in a PowerPoint presentation, which could work, but it is tedious and you need to know the structure in advance. Fortunately, that's why we have the Open XML SDK. The Open XML SDK simplifies the task of manipulating Open XML packages and the underlying Open XML schema elements in a package. The Open XML SDK encapsulates many common tasks that developers perform on packages so you can perform complex operations with just a few lines of code. So, what do I mean by that? Well, let's take, for example, accessing the description property like we did in the previous slides by working directly with the XML. Using the SDK, we can use strongly typed classes for XML parts and elements, giving us validation and IntelliSense. So now we can open the presentation directly, then access its slide parts, and use a for each loop over the slide parts to access the pictures, and then another for each loop to access the innumerable pictures and get the descriptions. Now, with the SDK, we can do 19 lines of code, which took over 90 working with the XML directly. And along with that, we get strongly typed classes and help with error prevention. We could also use link queries to make the code more compact. But in this case, we need access to the slides as well as the pictures in order to find the image files to send to the Azure AI Vision API. So far, we've accessed the picture elements in the slide part, but we also need an image file to send to the Azure AI Vision service. To do that, we find the image's relationship ID and use it to find the image part. Here again, with the Open XML SDK, we can use IntelliSense to help find the relationship ID property, and then the built-in getPartByID method finds the image part. If we were to do this without the SDK, we would have to examine the XML directly to find the IDs, then open the slides relationship file and find the location of the image file. Now, this can be difficult and error-prone, especially as the file structure of an Office Open XML file can differ and still be valid. Now that we have the description property of the image along with the image file itself, we can use the Azure AI Vision SDK to create the image descriptions. So what is Azure AI Vision then? Azure AI Vision services give you access to advanced algorithms that process images and return information based on the visual features you're interested in. You can use the Optical Character Recognition, or OCR service, which uses the new Read API to extract printed and handwritten text from photos and images. There's also the Face service that can detect, recognize, and analyze human faces and images for scenarios such as identification, touchless access control, and face blurring for privacy. If you need to analyze video, video analysis includes video-related features like spatial analysis, which analyzes the presence and movement of people in a video feed, and video retrieval, which lets you create an index of videos that you can search with natural language. In addition to these, there is the image analysis service, which is what we're going to use with this application we're creating today. Azure AI Image Analysis 4.0 is now in general availability and has multiple capabilities, including the ability to read text from images, detect people in images, detect objects, tag visual features, and many more. But today we're going to focus on generating image captions. Azure AI Vision can analyze an image and generate a human-readable phrase that describes its contents. The algorithm returns with text and a confidence score. In this example, we see that the AI believes that this is a baseball player holding a bat with an 82% confidence score. And in this case, we can see that it's correct. If you want to try Azure AI Vision services or any of the other Azure AI services, you'll need to create a free account at portal.azure.com. Most of the Azure AI services have a free tier that lets you experiment with the tools. Azure AI Vision, for example, allows 5,000 free transactions a month, which should be enough for any kind of experimentation. Once you have your Azure AI Vision subscription, there are SDKs available for C#, Java, JavaScript, Node.js, Python, and a REST API if you're not using one of those languages. If you aren't ready to start coding, or you can experiment with the Azure AI Vision Studio, which is a set of UI-based tools that let you explore, build, and integrate features from Azure AI Vision. You can experiment in real time with provided images, or you can use your own images and start experimenting with the services and learning what they offer without needing to write any code. So once you've created your Azure AI Vision resource, find your key and endpoint for the resource and use them to create an instance of the image analysis client. In this case, I'm using the C# SDK because we're writing this in C#. With the client instance created, translate the image you want to analyze into binary data and pass it to your client instance. The return data will be the caption and other metadata, which you can then assign to the description with the Open XML SDK. When the update is done, save the presentation, and that's it. You've updated the description. Now that we've completed the application, we can look at the code and see that it takes only 68 lines of code to find all the pictures in a PowerPoint file, call the Azure AI Vision API, and add the missing descriptions. To test it, we'll use this PowerPoint file with two images, a giraffe and a motorcycle. To view the descriptions, select the picture, then picture format, and then select the alt text. And as you can see, neither of the images has a description. Now we'll close the file and run our application. Now that the application is run, we can see that the captions it found were a giraffe standing in a field with a confidence score of 0.9063 and a red motorcycle with flames on it with a confidence score of 0.7774. Now, opening the PowerPoint file again, we can see that the images now have the alt text from the Azure Vision API added to their descriptions. So, what are the next steps if you're interested in learning more about Azure AI or the SDK? If you're interested in building or extending the application we created today, the code is available on GitHub at github.com/interopevents/add-image-descriptions. If you want to learn more about Azure AI Vision Services, the first step is to create your free account on portal.azure. Once you've created your account, you can use the Vision Studio to experiment with what's possible with Vision Services. And in addition to experimenting with the tools and seeing what's important, it's important that you learn about the responsible AI practices. To learn more about the Open XML SDK, the best place to start is the documentation, where we have documentation and tutorials to help you get started. We also have an active community on our GitHub page and on Stack Overflow, so please reach out to us on those platforms. If you want to experiment with the file format itself, there's an extension for VS Code that makes it easy to examine the Office Open XML files called the OOXML Viewer. I want to thank you for watching my presentation today. I hope it was useful and informative. Please enjoy the rest of your event.